different antibodies, and we already know the structure of the antibody. It's like a Y shape, and on the uh, upper terminal is a V region, and the reset though there are two identical heavy chains and light chains together, linked with the deficit, and on the level of the domains, the region, the variable region include VL and the VH. So from the structure of the antibody, it formed two identical V region, and the rest of the antibody molecular is the C constant region. So, and there are generally we talk about the types of the antibody, including five kinds: IgG, IgM, and IgA, IgE, and IgD. The IgG is the major, account for about 75% of the antibody in our bodies. And the IgM is the largest size of the antibodies because it is formed as contain the is a pentamer, five monomer together to form the pentamer, and another special antibody is the IgA because it formed a dimer. The IgA, the S, the secret IgA is a dimer, and it is the only one antibody to transformed out of the cell or out of our body, such as the sweet, the tame, and in our another place out of our body, out of the cell, transport the transport out. Yes. Now this class we will talk about the latter part, three part of this part. It is the biological activity of the antibody and the generation of antibody diversity and the molecular antibodies. So we already know the structure of the antibodies. The region V region is a variable I think is a region to against the different epitope, and the C region is to perform the function, and this part we'll talk about it in the later. So the antibody, the biological activity of the antibody is a function in the absence of other factors, and the role of antibody in complement activation, and the role of antibodies binding to affect cell. How to understand the point one? Antibody function in the absence of the other factor is compared to the part two at point 2 or point 3, because the point 1 is said that the antibody performs the function only itself is okay, do not need the help with another contents, such as particle antigen, such as the or foreign protein or the virus. The virus very very small in size, so it's like a particle. After the binding of the antibody to after the after the antibody binding to the variant or the foreign protein, the immune response will be finished. It's okay because the size of the foreign protein and the virus is very very small. It's needn't to further step of the response. But on the other hand, and the another foreign substance such as the fungi and the bacteria is bigger and very bigger than the protein or the very bigger than the virus. It so the antibody binding to the bacteria or fungi is not enough to treatment or cleaning the antibody antigen. So it needs the help with the macrophage or the NK cell or CTL cell to help clean the foreign substance. So the point one I explained here is that the antibody function in the absence of the other factor. The other factors means NK cell, macrophage, or another or CTL, and another cells. And the point two, the role of antibodies in complement activation. Here also will introduce it, and another role of antibody binding the effector cells. One by one to introduce it, one by one. Here is what I just to say before. The neutralization by antitoxin antibodies. We can see the toxin binding to the cellular reporters, and then the endocytose of toxin receptor complex. And here in the third step, the dislocation of toxin to release the active chains which poison the cells. After this 1, 2, 3 on the left picture here, step 1 to touch the receptor, bind to the receptor, and the second step is to by the endocytosis and enter to the cell and then release the toxin. It is the mechanism of the toxin to our normal cell. It is not a good thing for our body. So if the antibody come here exists, if the antibody exists, the antibody will bind to the site of the toxin for binding to cellular receptor. We can imagine that due to the antibody binding to the toxin cannot to bind to the cellular receptor anymore. So yes, due to the antibody binding to the toxin, so the toxin have no space to bind into the cellular receptor. As a result, the toxin lost the ability to bind to the cellular receptor and lead further terrible infection. Terrible infection. This is a neutralization by antitoxin antibodies. As the same as the antitoxin, the antiviral is the same to the antitoxin. Here also named neutralization by antiviral antibodies. The virus get the binding to the receptors in the surface of the infected cell, normal cell, and then enter to the cell and release the DNA. This is the classical pathway for virus infected into the normal cell, and similarly, if the antibody against the virus, the antibody will bind to the virus, and the virus lost the ability to bind the receptor on the surface of the receptors. So here, this process did not need the help from another cells. That means antibody function in the absence of the other factor. And on the other hand, the bacterial neutralization by AB is similar to above. Also, the existence of the antibody and the bacteria cannot infect the normal cell no longer. And the point 2 is the role of the antibody in complement activation. And here the key region of antibody to perform the function is FC region. And the FC region will responsible for 4 kinds of functions. The first one is to activate the complement system, and another is binding the cell to perform the opsonization and mediating ADCC. Opsonization, it is a micro opposition molecule that come active to the surface of the microbiome and the cell or and macrophages, and that increases the persistence of phagocytosis of the microbiome. Antibodies, including IgG antibodies, which are recognized by the Fc gamma receptor or phagocytocyte. Here, Fc gamma receptor. This is the special receptor for the IgG. It can recognize the Fc fragment of the IgG. And the fragment of complement proteins, which are recognized by CL1. We can see the diagram here. The complements, the combination of microbial by macrophages. The body will use and produce antibody IgG and release blood. And then the antigen is also always released in the blood. And then after the IgG binding. This binding is the first step. It's not finished because the antigen is very big. The binding of IgG and the antigen is not finished the response. It leads a second step, such as the complement binding to the IgG, which activate the pathway of the activation of complement system. And on the other hand, the binding of IgG and the antigen will reconcile and will be counterized by the macrophage and all the neutrophils. These two cells to bind to IgG's FC fragment, and then uptake the complex components. On the other words, the neutrophils and the macrophage will eat the IgG and the antigen together to the cell and then digest the antigen. So here we can see the IgG is a link between the neutrophil or macrophage and the antigen. We can imagine that if the IgG not exist, the neutrophil or macrophage is very hard, maybe it's not easy to get the antigen. So the IgG help the IgG labeled on the antigen will help the neutrophil or macrophage get and eat the antigens. Here is the other kind of diagram to describe the process. And the FC gamma R, the FC the gamma R, what means this? This abbreviation FC gamma R is the gamma. Gamma means the IgG FC receptor, FC gamma R, which recognizes the FC fragment of IgG. The FC gamma R and the complement receptor cooperate to induce greater phagocytosis. Each part of the picture each step of the process will have the description below the picture. We can such as the bacteria is coated with complement IgG antibody, and when the C3b binding to the CR1 and the antibody binding to the FC receptor, the bacteria are phagocytosized, and then macrophage membrane in membranes and creating a membrane bonding vesicle. This vesicle named the phagosome. In the phagosome, and there are a huge number of lysosomes and will degrade the bacteria. So this process is thanks to the existed of antibody and the C3b and the relative receptor, such as FC receptor, FC gamma receptor, and the CR1, the complement receptor 1. And another second process mediated by the antibody and with the help of NK cell is named ADCC. The ADCC means antibody dependent cell mediated cytotoxicity. Similarly, the antibody binding to the tumor cell, or here is means target cell. Generally, the target cell is a toxic tumor cell, or the cell affected by the virus, but the cell is not degrade. The NK cell will bind to the antibody and then kill the target cell. So like this, it can kill the abnormal cell, such as the tumor cell or the infected viral infected cells. ADCC. So for now, here we should be understand the antibody. Only the antibody is not enough to treatment the antigen. It's just like a linker or a label. After the antibody linked to the antigen, the antigen will be marked, and then the neutrophil or macrophage and the NK cell will easily to treatment with the antigen, especially the tumor cell or the viral infected cell and another bigger size bacteria and fungi. So we should be understand that the antibody is a link. And another part of this class, I want to introduce the generation of antibody diversity. This antibody diversity is included two aspects. The except one is the specific antibody could be induced whatever antigen is. What means here? It means the no matter what the foreign substance come into our body,
Sir,
sorry, say,
can you invite Nisha, sir?
你说你 any question?
Can you invite Nisha, sir? She cannot join the class.
What? Pardon? Sorry.
Can you invite Nisha, sir? She cannot join the class.
I can't understand your meaning. You write on the table.
Check the chat, sir, in the group.
Which group? I see.
Could you please check our Ding Talk group, Losha?
Take up what group?
Our Ding Ding group, Losha.
Send the PPT to the Ding group.
Check our Ding Ding group, Losha, because our friends have some trouble.
Oh, okay.
Yes, Losha, thank you.
Is it to the Tindin? Some trouble in the Tindin? As I already tried to join the class, but cannot join. Can you hear me? Nisha can't into the class. Enter to the class. Right. Nisha, since I already tried to join class today, but I can't join. Nisha, come in and try it again. I see the message. Okay. Nisha, come in. Are you coming? Do you come in? Nisha? Okay. 第九 come 第九 knock. You are not allowed in. Oh, sorry.
Maybe Lausha have to
I
invite.
will to advise you. Advise and Nisha. Okay. Okay. Now okay. Now okay. Okay. Nisha.
Okay, Lausha.
Okay. Sorry, my fault. Don't worry. I will send the PPT to our group. This part is not hard to us. If you name the on the PPT, you can understand what I just say. Okay. Okay.
Okay,
Continue.
Lausha. Thank you.
You're welcome. This part is to the generation of antibody diversity is include two aspects. The step one is the specific antibody could be induced whatever antigen is. What means this system? This sentence said we can imagine that the 10,000s of the antigen around in our body in the life, and whatever the foreign antigen coming into our body will induce the specific antibodies. How can our body do it? And another one is the multiple types of antibodies against the same antigen. What I mean about this sentence is that for the same antigen, there is not only a single type of antibody. will be produced, because we can also imagine that after the foreign substance into our body and our bodies, and the first the IgM were produced, and the contents of the IgM will go to the higher value, and then the IgG will be induced. This is not a, it is not a, it is totally different to the IgM. After the IgG produced, and the IgG will account for a major part of the antibodies, and then on the end, on the close to the end of the response, the maybe the antigen is cleaned inside in our body, but outside our body, or the for example the mucosal tissues, the outside of the bodies, there also some antigen exists there. How to do? Well, the IgA will be produced. The IgA not only worked in the inside our body but outside of the bodies. It can transfer the out of the cell to kill or to treatment with the against the antigen. So these two aspects of the antibody diversity will to explain it. Here showed the picture. Here is the for the mouse, different foreign substance have a different epitopes, and then the mouse will induce a different antibody to against them. Here the key point is the diversity of CDR. CDR is what it introduced on the last class. The CDR is a partial region in the V region. Is a V region. It is we already know the V region is a very high variable region here, but the CDR, including CDR1, CDR3, or CDR2, the 3 points is much more higher variably than near them. On the other words, if the region, the amino acid is a variable in the V region, and the CD1 to CD3, this 2 point, the amino acid is a much more higher mutational value than the closer amino acid. How to get the variable level? It is a famous hypothesis is the genes of antibodies, the antibody genes rearrangement. At first, I want to say is sorry, I should use the picture before. Here, we use the picture before. Here we can see this on the structure of the antibodies and the V region and the recessed is the rest is the C region, and the V region, for example, for the light chains, I mark here. You will be understand the convenience. Here we showed I mark some different here I showed here is the light chains, net chains. Just the net chains as the red and as the red red box inside the red box, we can see the light chains, and the light chains actually in the genome in the I think is genomic, yes, genomic. What I mean genomic. I use the English to express it. Genomic, yeah, genomics. On the genomics level, the L chains, which come the L chains gene is uncontinuous. Continuous, right? Uncontinuous. EUS. Uncontinuous. Sorry, you don't use this. I can see it's not at continue. It's okay. And not. You can see. Can you see the on the genomic level, the the genes encode the L chain is not continue. We will see the picture later. This DNA, the DNA fragment depart into three parts: the V region, and the V region, and the D region, and the G region, and the VDG region. And the VDG region content so many choice. Why is called choice? choice. Okay, remember this two sentences. You can see here the genes encoding the light chains not continuous, and it depart into three parts. The V region, VDJ, three regions, and each region contain many choice. How to understand it? We can see that's a picture. Sorry. Here we can see the diagram in the below or the under the sentence. Here is VH. You can see VH, DH, and JH. It put out. It means here showed before. Sorry, or H's and the H chance. Also departed into VDG2. VDG2 and each VDJ have different choice. We can see the picture showed here is the heavy chain. The heavy chain he showed there is the green box and the purple box and the red box, red shape. Here we see the VH, DH, and JH. The VDJ means the each region. VH means the VH here means the V region of the heavy chain. DH means the D region of the heavy chain, and JH it means the J region of from on the heavy chain. And then if the genes to encoding to the antibody, the VH and the DH and the JH only one choice to make up single antibody. We can see a number in the VH, DH, JH here, 40, 45, 23, or 6. It means every antibody to form or to express the VH have 54 choice, and the DH have 23 choice. Because one single antibody, only one piece is okay, or a number of the D region is okay. We can see the sentence here. The D to the DJH reagreement. The step 1 is the section contained an n number of D region and n number of J region knock out, and then together the DJ linked. And the step 2 is the VH and the VDJ and linked. So at the first on the final in the V region, including 3 parts of the VDJ. As a result, the opposition of the VDJ regions were together to make up a single antibodies. Similarly, the process is is the same to the light chains. Here we can see here we can see videos.
So I've been getting a lot of feedback on various study materials you received from
共享
anywhere from Robert and Italy. So I thought I would create a video that kind of
Did you see the videos?
explains it a little. So I've been getting a lot of
Did you hear the video?
feedback.
Yes, Lausha, but I think the volume is too small.
No, Lausha.
Where from Robert and Italy. So I thought I would create a video that kind of goes over the whole thing, explains it a little more so that you guys can kind of see where the details are important and where really just a global understanding of how antigen anywhere from Robert and Italy. So I thought I would create a video that kind of goes over the whole thing, explains it a little more so that you guys can kind of see where the details are important and where really just a global understanding of how antigen receptors perform will vary. And we're actually going to do this using the mechanisms of diversity, because really that's the whole point of BJ is creating diverse receptors. So we have 5 genetic mechanisms of diversity. We will be covering somatic hypermutation beginning in Smith and maybe a little bit in KPS, but in the initial pieces of Robert May that you named about before. So that's inheritance, recombinational accuracy, and random assortment. So the first thing that we have to think about is any time that we are talking about BJ, we're talking about T cell receptors and B cell receptors. So let's start first by just looking at their structure. So when we talk about a B cell receptor is basically just an antibody that's stuck on its surface. Okay? And then an antibody has a heavy chain, as I've drawn here. And then it also has a light chain. Okay? Then when we think about the different portions of the antibody, we've got the areas that bind antigen, which are like right here, right here. But then you also have the portions that allow it to be attached to the cell. So determining whether or not it's going to be membrane bound or if it's going to be secreted. And then you also have the portion of the antibody that's going to determine what class of antibody it actually is. So this tells you whether or not it's like an IgM or an IgG. So that's just to kind of orient to the structure of the actual body molecule. Okay, so when we talk about T cell receptors, it's actually not that. It's almost like you took this little piece of the B cell receptor, just this antigen binding piece, moved it over here to be a T cell. Now, obviously, they're very different structure. But the concept is the same. So in the B cell, we have a heavy chain and we have a light chain, right? And that's what I showed here. With T cells, we actually have an alpha chain and a beta chain. So that's kind of what I'm drawing over here. So your alpha chain here, your beta chain would be like here, okay? And then they stick through the T cell, right? Because they're always surface bound. So we don't have quite the same level of complexity and structure on the T cell receptor. Now, what are we actually talking about?
Excuse me. Here, the values show the TCR and the BCR are the immunoglobulin. Is very, very similar to the antibody, and the arrangement of the TCR or BCR is identical, or mostly identical to the rearrangement of antibodies. So if we we should be accept the same concept each other.
About with VDJ. With VDJ, we're only affecting the part of the protein that is going to come in contact with the antigen. So for T cells, we're talking about this area right in here. It's actually going to bind our antigen of interest. Okay, so this is where our antigen is going to bind. We only care about the part that's actually touching our TCR. And the same can be said on the B cells. So we're only talking about this part right here, where the antigen is actually going to bind. We're not talking about the rest of the molecule. The rest of the molecule is already encoded for, accounted for, and we know what it's going to look like. And this is especially true for T cells, because remember, with T cells, these areas right here, they need to be able to bind to and recognize self-MHC. That's kind of their whole deal. They can't, in these invariant regions, recognize self-MHC, then they can't see the antigen. It doesn't matter. So we're really only affecting these areas where the antigen is physically touching the T cell receptor and the T cell receptor. That's the whole point of VDJ. And the reason for this is that we need to make an unconscionable amount of antigen receptors. If we had to encode for every single antigen receptor, we would need, over the course of our lifetime in our DNA, it would overwhelm the human genome. It would be way more than the human genome, because there are just so many unique antigens in the world. We would cease to be humans and just be antigen replicating protein. So instead, we've made building blocks. We have building blocks that we use to create these locations within our TCR. So how does this work? I want you to think of it for the moment very simplistic, okay? So this is our chromosome. It has a whole bunch of genes. The first thing we're going to note about it is that it literally has multiple copies of the same gene type, but they're each a little different. So it has multiple V regions, V exons. It has multiple D exons, and it has multiple J exons. Okay? So when we think of it that way, think about how many. That means this is V1, 2, 3, 4, 5. These are all of our genes. And this is D1, 2, and 3. These are our D genes. And this is J1, 2, 3. These are our J genes. I don't know exactly how many there are. I think I listed them in some study, but I don't really care. The idea is that we inherited a whole bunch of them from mom and dad. Thanks, mom and dad. So what happens is we can use these to create our unique receptors. And we do that by recombining them seemingly random. Okay? So we're going to start with looking at both TCR. Really, the process is the same as the names change. Okay? So for a TCR, we're going to start with the beta chain. For a BCR, we're going to start with the heavy chain. What we're going to do is we're going to choose, say, D2 and J1, put them together with, say, B. Okay? That is a rearrangement, either a beta chain or a heavy chain on this cell. Okay? We took one B region, one D region, one J region, made a chain. Great, that'll work. And then let's say another cell made B2, D3, J2. This one is going to form part of the specific structure for antigen A. And just by virtue of it being a different exon, this one is going to form part of the structure that will be specific for antigen B. Because different B, D, and J have different specificity, okay? So let's say, though, that second cell also used B1, B2, J1. Now, you would think that looking at this, it would also be specific for A, but you would be wrong, and here's why. Because of combinational inaccuracy. This is an very quickly. It's error prone. Like it that way. Why? Because errors bring diversity. And the other thing we have, particularly in the beta and heavy chains, is the enzyme TDT. TDT adds your N nucleotides. So it's going to add N nucleotides anywhere you have a chain. So that means this is B1, D2, J1. It's actually B1 with a couple nucleotides here, and D2, a couple nucleotides, J1. This one is going to be a totally different set. And just by virtue of having these extra nucleotides, now we're back to this one being specific for antigen A, this one being part of the complex that was specific for antigen B. So once again, we've increased our diversity. So all we've done at this point is made a beta chain or a heavy chain already effectively worked. Three of the big methods for creating diversity. We inherited a whole bunch of different A, D, and J segments. We reorganized them randomly, kind of like boxcars on a train. And then we actually did kind of a bad job of it because we replicated it weirdly and added in random nucleotides using TDT anywhere we wanted. And that's great because it increased the diversity even more. And it means that even though we were using the same J regions, we actually have a different specifics for different. Okay. So just doing that, a lot of work, right? So we successfully made on just one chromosome a VDJ. That is either going to be a heavy chain if we're talking about a B cell, or a beta chain if we're talking about it. Because it's so much work, I don't want to waste it. I don't want to have to do it again. We're 50% of the through making a functional. We're going to check it. We're going to do this in two different ways. If it's a B cell, it's a heavy chain. Now going to enter that large. Right? So that means this chain is expressed within a vesicle in the cytoplasm of the cell. And it's going to be expressed with V pre-V, right?
Okay. Okay. So if we this is the partial part of the verdicts. If you have interesting to further know about information, know about information about it, you can use the website to continue to which. Okay, go on our class. Here we said the DNA or the antigen or PCR or TCR to reagreement and to display the diversity of the final production protein production. So, and the last part of this class is the monoclonal antibodies. Here is a clinical application on the about the antibodies. If you it is more important to the medical clinical medical medicine. Here is the or the product process and to select the productions, the molecular antibodies. And here is the antibody application of the molecular antibodies. Here is the famous molecular is PD-1 antibodies. PD-1 antibodies. This achievement is in the 2018. The discover person of the antibody PD-1L is obtained the Nobel Prize in 2018. Here is the description of the anti-PL1 to the work the mechanism of this molecular. And here is the antitoxin biological agents. This is a toxin to produce the antitoxin. Use the horse, and then after the cleavage by the person, we can got the FAB2. This part of the FAB2. This is more safety than the former molecular, because this production is not have the FC fragments from the house. Because the PFC, this fragment from the house, it also in some degree as an antigen to our body. And the last, we can see the emphasis. We should after this class, we should be master the concept of immunoglobulin and antibody, and the master the relationship with the structure and function of antibody, and the master property and biological activity of the 5 class of antibodies. Now I think this class, the content of this class is finished. You have any questions?
No, Lausha.
Okay, if you have any question, you can leave the message to me. Okay.
Okay, Lausha.
Okay.
Lausha.
Class is over. Bye bye.
Okay.
Thank you, Lausha.
Thank you, Lausha.
Bye bye.
Bye bye. See you. Bye bye. See you.